Hi guys, my name is Yannick Reis. I hope you're doing well and I welcome you to a new video. State handling or event handling is essential in almost every Android app. At one time in the development process, you will come to the point where you need so-called one-off events or one-time events. Such events are, for example, the result of an API call, and in that case, you want to show a success message. Another example is maybe that you process a workflow and at the end want that the user navigates back. In that case, you trigger an event and that event should get consumed once and triggers at the end the navigation. In the legacy way of implementing our UIs, in most cases we use live data. For such one-time events, there was a workaround called single live event. May some of you know this concept because it was hardly used and is still today widespread used in many Android apps. But as time goes by, there were introduced new opportunities to implement this process. With the hot flows from Kotlin, shared flow and state flow, we had a new way for implementing these one-time events. However, with the declarative UI approach of Jetpack Compose, things have changed. The known Android team, which you may be familiar with, often provides suggestions on how we could implement or should implement our Android architectures. So it came that Manuel Vido, for example, on the Droidcon Berlin 2022, held a presentation about implementing modern Android architecture, and he also wrote an article called ViewModel one-off event anti-patterns. One of the main takeaways from the Droidcon talk was that it's in general a good idea to hold your view state from your view model in a data class inside the view model. That view state is then presented to the UI layer, and the UI layer on the other hand just presents the state. In the article about the one-off anti-patterns I was just talking about, on the other hand, he also showed us how we should handle one-time events in Jetpack Compose. But let's first take a look at what this anti-pattern he was talking about actually looks like. In this case, he's not using a shared flow but a channel, but he directly says navigate to payment results screen. So if this channel receives a new value, which is right here, we send is payment successful, the results screen should navigate further. So if we come to this section here, he not only mentions that the state can get lost by using the approach of channels or shared flows, but he's also telling the UI to take an action as an anti-pattern so that the view model shouldn't tell the UI what it should do with their state. The third point he mentions here is that not handling the one-off event immediately. And as a solution, he proposes to use the state flow and hold the values inside that and directly observe these values and collect them and handle the events. Before we take a look at the anti-pattern in a practical example, let's take a first look at our example app from today. We have a simple UI here, only a trigger event without a timestamp button and a trigger event with timestamp. So when I click on without timestamp, as you can see, we just receive a snack bar here without any further message. And if I click on trigger event with timestamp, at the end, we receive an event with a timestamp. So these are these one-off events. I trigger here a process, and at the end, I have a result and I show it to the user. Let's start by taking a quick look at the content composable. So we have a modifier, a function here for starting the process without a timestamp, and also one for starting the process with timestamp. And then we have our loading state. The layout itself is just a column. We have a top bar and here a circular progress indicator, which we just saw in the app example, and two buttons which are only enabled if the state is currently not in the is loading state. And if we scroll up, we can take a look at how this state collection here actually works and also the snack bar stuff. So we have here the view state, which currently only holds the is loading state. And we have here our two shared flows, which get collected in this lifecycle repeat on lifecycle block. We launch a coroutine for each of these collection processes, and the whole stuff is wrapped inside the launch effect, so it gets only executed once. As you can see, for the on-show process notification, we show the event success, and on the other chat flow, we show the timestamp within this snack bar. So that is the UI handling part, and then let's quickly jump into the anti-pattern view model. As you can see here, we have a state flow which holds the state, and these two shard flows, one without and one with the timestamp. And here's just the function that triggers the dummy process. As you can see, it's just a placeholder delay with 3-second delay. And here we activate the loading process and also deactivate it. And down here, we emit the chat flows. And here we emit the timestamp, which gets formatted by the getTimes instance of the simple date format. And now that we saw how we shouldn't do it with Jetpack Compose, how should we do it? And if you recall the approach shown by Manuel Vido, we will no longer have these two chat flows, but put the event inside our main view state. So we start at the main view state. And here we introduce a new variable, which is process finished. And we just use a boolean here. Initially it's false. And the second one is process finished with timestamp. And we use a nullable string and initialize it also with null. So that are now our two view state representations for the events. And now we need to adapt the entity pattern view model. And we first get rid of these two chat flows. And now we just need to update these two lines. As a replacement, we will just update our view state. In this case, we want to say, okay, the process is finished. And therefore, we use the current state, which you get when you update your view state. Because it's a data class, we can just say copy. In this case, we say process finished and just call it true. In the second case, we can just copy this and we once again use this function for creating the timestamp. And we say process finished with timestamp and also set the value to the timestamp. So by that, we updated the view state. And if we now go back to our main activity, or to be more specific, to the main screen, we will need to adapt these two positions because we don't no longer collect from chat flows, but need to react on our view state. So what we do here is we introduce a new launch effect and we say view state process finished. And now here, the first one, we only need to call the snack bar state once again. And the same goes for the timestamp case. So also here, view state, and this time we use the process finished with timestamp. And now also we use the timestamp here. But in this case, we also want to have the timestamp itself. Therefore, we use the let function and we say timestamp. And in this block, we can once again use the timestamp so that we only call it if the value is really not null. And afterward, we now need also to tell the view model that we consumed the state. And how we do that is we just introduce two new functions and say consume process finished and also consume process finished with timestamp. And here we can copy this line and say null. So we set it back to the initial state. And here also for the process finished, we say false. Of course, we now also need to consume it. Therefore, after we showed the snack bar, we say consume process finished with timestamp. And here we say consume process finished. So now we migrated the anti-pattern to the style that is proposed by the Now and Android team. But in my opinion, a few things are off here. One thing is that we always need to make sure to call the ViewModel consume function. And in the case in which we want to process the result, we always need to access this variable twice and need to check if it's really not null and so on. And also have, once again, the problem that we need to manually call the consume process finish with timestamp function. And one more thing that comes into my mind is that we can no longer distinguish between a regular state representation and an event in this case. So what is what? Because we just wrote this code, we know it, but will a developer in 3 months still know it? I don't know. But what if I told you that there's a library that facilitates this process and makes it clear what is an actual event in our view state and what is just a regular state representation. As you can see in this documentation, we have a state event, which is a representation for a simple event without further content. And we also have the state event with content, which, as you can see here, for example, takes an integer. Each of these state events can toggle between two states. The initial state is consumed, and the state when the event is actually invoked or active is triggered. But that's not all. There's also an override for the launch effect, which is event effect. And as you can see, because it's always the same pattern, we need an event, and we also need to call the ViewModel to consume this event. You can input these two things, event and onConsumed. And after your execution block, it will automatically call the onConsumed function. In the case that you want to process the result, you will also receive the result in your function block here. So back at our example, let's introduce this library. In your app level build Gradle file, make sure that you have at least this version of the compose state events library. You can also receive all these dependencies from the GitHub project. I linked you down in the description where you can exactly copy all this code. And let's go back to our main activity. And now let's introduce this library. We start by migrating our main view state. So for the simple event, we use state event and now set it to the initial state of consumed. We will also no longer name it process finished, but process finished event. And also here we call no longer process finished with timestamp, but also appended with event. And here it's a state event with content, and the content is a string, which is finally the timestamp. And here we initialize with consumed. The next step is to go back to our ViewModel. And now there's not much to do. We just need to set these values a little bit different. So it's no longer true, but triggered for the simple case. So the event is called. And for this case, I will quickly use an own variable for this one. And here we will say consumed, triggered, sorry. And the content is the timestamp. And on the other hand, the other way around, when we consume these events, we say again, here we have consumed and here also consumed. So now, as you saw, we used a different approach for these launch effects. So it's no longer launch effect, but event effect for the simple case. And here we now need the event which is from our view state and is the process finish event. And the onConsumed is on the other end, this function here. And we can use a function reference. And now if the process block here gets executed afterward, the consume process finish will automatically get invoked. The next thing is also that this function block will only be invoked when this launch effect, which is under the hood, reaches the triggered state. Now for the event effect for the second case, we can actually consume this pattern here, copy this pattern here, and say processed finish with timestamp event. And now you can see that in this function block, we already receive it string, which is of course our timestamp. And now we can completely get rid of this one. So copy the consumption, the correct consume function here. And yeah, now we can get rid of this stuff here and only use the snackbar host state show snackbar. So as you saw, this library is really handy and easy to implement. Even if you ask yourself now, okay, that sounds good, but why not use the conventional state? Why the compose state events library? As you saw, it's not only easier to implement this process for handling one-time events in Jetpack Compose, but it also makes it directly clear in your view state what is an event and what is this really state representation. We don't tell the UI directly what it has to do with this event, but we know this event somehow needs to get consumed. So it's also less error prone in the future when new developers come on the project and need to maintain this project and they no longer know what is an event and what is a state representation, because in this example we had only like 2 events. What is if you have like 20 or something like that? So in conclusion, I can only encourage you to try this library out. I hope you had some takeaways. If you want to take a look at the full project, click the link down in the description. I linked the GitHub repository where provided all the code samples here. And if you want to dive deeper, you can check out also my Medium article I wrote for the Pro Android Dev about this topic. And finally, I just can say, like the video, subscribe to my YouTube channel, activate the notification bell, and I hope to see you soon.